Looking at another example from section 6.3, this problem looks at where we might want to estimate the standard deviation. So if we look at this problem about refrigerator replacement consumer reports, they indicated that the average life of a refrigerator before replacement is 14 years, and they tell us that's mu, our population mean, with 95% of the data ranging from 9 to 19 years. Well, what that's telling us, this one refers back to a previous problem, and the empirical rule basically tells us that 95% of the data are within 2 standard deviations above the mean and 2 standard deviations below the mean. So that's a total of 4 standard deviations that most of the data lie within. So it gives us this approximation, a way we can estimate the standard deviation. So as long as it's a symmetrical and bell-shaped distribution, we can estimate our standard deviation by taking our range and dividing it by 4. So that means taking the highest value, 2 standard deviations above the mean, and subtracting the low value, 2 standard deviations below the mean, and dividing that by 4. Okay, so in this problem, it tells us that the range is from 19 to 9 years old. So we can estimate our standard deviation, which, remember, the population notation for that is sigma. So we know sigma is approximately equal to our high value of 19 minus the low value of 9 divided by 4. 10 divided by 4 is approximately 2.5. Okay? So the problem had told us that mu was equal to 14. We just approximated our standard deviation to be 2.5. So we can now look at part B here. What is the probability that someone will keep the refrigerator fewer than 11 years? So now we're looking at the probability that X is fewer or less than 11 years. If we draw our picture to look for that probability, we know our mean or center is 14. So we know 11 is to the left here. We want less than, or it's pointing to the left, so we want this area to the left of 11. So now we can use our normal CDF, as I showed you in a previous video. Our lower bound is the left area of the shaded region. Now remember, this goes on, so that's where we use our -1 E99, comma, the upper bound, which is of the shaded area, which is 11, comma, mu and sigma, 14 and 2.5. So we do our normal CDF, whoops, turn it on. Second distribution, normal CDF. We do negative, remember that's the button way at the bottom here for negative, not the minus, the negative. 1 second comma to get our E, 99, comma, 11, comma, 14, comma, 2.5. And we get 0.115, 4 decimal places would be 1. Make sense? So we can do a similar thing for part C. What is the probability that someone will keep the refrigerator for more than 18 years? So we do the probability that X is greater than 18. We draw our picture. Our mean is 14, so I know 18's to the right of that. Shade the area that you want. We do our normal CDF. Lower bound of the shaded region now is the left-hand side, or 18. The upper bound goes on forever, so we have 1 E99. Whoops, sorry about that. Lost my iPad. Comma 14, comma 2.5. Okay, I'll let you guys do that one. So go ahead and put that in your calculator. Maybe hit pause. And we're going to do part D here before I end this example. The inverse normal distribution, assume that the average life of a refrigerator is 14 years. Let me stabilize my iPad here. With the standard deviation given part A before it breaks. So we know our mu is 14 and our standard deviation was 2.5, right? Suppose that a company guarantees refrigerators and will replace a refrigerator that breaks while under guarantee with a new one. However, the company does not want to replace more than 5% of the refrigerators under guarantee. For how long should the guarantee be made? Round to the nearest tenth of a year. Okay, on these inverse normal distributions, it's actually giving you the probability. Okay, so if we look at our curve, our center's 14, right? What this is telling us is this area right here is 0.05. It wants to know our x value. So it's giving us the probability. The easiest way to do this on the calculator is the inverse norm key. So when we put this in the calculator, we always put the area to the left that we're looking for. So in this particular problem, that would be our 0.05. Okay? Then we put in mu and sigma. Okay? We could also, if we wanted to calculate the z value, we could use the reverse formula of our transformation formula. And we use x equals mu plus z times sigma. But we have to look up z inside the table. So I find for most students it's just easier to do the inverse norm on the calculator. So we do second distribution. The inverse norm is right underneath the normal CDF. Put in our 0.05, comma, 14, comma, 2.5. So when it says to the nearest tenth, looks like it would be 9.9. About 9.9, I believe we're in years. Make sense?